welcome everybody this morning to something to talk about here at the Bainbridge Island Senior Community Center. And we are more than happy to welcome Doug Salot and Rick Gordon. And they are with the Electronic and Technical Arts Studio at the Barn, the Bainbridge Artisan Resource Network, which is near and dear many of our hearts. So good morning.
Good morning.
Doug or Rick?
Let me start. I'm officially, so both Rick and I are volunteers at Barn, but they give us titles sometimes. So my volunteer title is lead of the Electronic and Technical Arts Studio at Barn. So that means I get to introduce Rick. Yeah, both of us, basically most of the Barn movers and shakers are volunteers. And if you're familiar with Barn, you know, I think, do we have now 10 studios, Rick? It varies in number sometimes between, I think, 9 and 11 studios. The Electronic and Technical Arts Studio is kind of I think it's the longest studio name at Barn, and it's a bit of a mouthful, but it basically, what it means to me is it's the digital design and manufacturing studio. So that is our niche. And I don't know about you guys, but when I was a kid, like in junior high school, I took wood shop and metal shop and small engine repair and drafting all in junior high school. Barn is all those things. So for me, this is my second childhood. And ETA, our studio, is basically takes that drafting and some of those other elements too, including woodworking, and applies digital tools to those crafts. So I'm assuming many of you like to draw, and many of you probably like to do woodworking. I like those things too, and I'm not very good at either of them. So you know, you can solve that not very good problem by practicing for on the order of 10 years, or you can apply computers and robots to the problem and quickly become a very highly skilled craftsman. So that's the approach I took, and I'll go ahead and walk you through it. So I'm going to go a little bit backwards in my presentation here, and then I'll introduce Rick to go deep into 3D printing, which is one of the manufacturing techniques we use here at Barn. So this is an object. Mother's Day is coming up, so I printed a little heart-shaped box. Ooh, you can see it's nice, a pink plastic box with a very perfectly fitting lid and with Mom engraved on the top. So this was, you know, 3D printed out of pink plastic. And then a lot of people don't like plastic, including me. So maybe you prefer figured maple. Let's see, where's my camera? There's figured maple and walnut for the box. Cool. Yeah, so this is kind of nice. And you can see same perfectly fitting lid. I'm not even going to try to put the lid on because it's so tight fitting I won't be able to get it off. But it's identical in size and shape to this plastic box. So I'm going to kind of show you how I did that, and with the hope that maybe it'll inspire you to try something similar. So I mean, basically, if you try to make this type of box yourself, you either need to be very skilled at carving, you know, very precise on the bandsaw, the chisel, or you can just let a machine do it for you. All right, so let me show you something that I use. This is a tool to draw, and it's called Fusion 360. So I'm going to try to show my screen here, a window. And this looks like it. All right. Okay, so can you see that?
No, you have to, oh, there we go. It's coming now. There.
All right, so this is what Fusion 360 looks like. It just gives you this kind of blank page. And, you know, we talked about drawing a bit. So the first thing for any three-dimensional model is a two-dimensional drawing. So I'm just going to quickly create a sketch here. This is the create sketch. You choose a plane to draw on, and then you have lots of tools. So I'm going to just do a simple circle here. Center diameter circle. I'm going to choose a center, and I'm going to make a perfectly round 4-inch circle. Okay, now if I wanted to make a circular box, that box is going to be cut out of the bottom, and it's going to have a recessed edge along the top. So I'm going to use the same design for both the top and bottom. And what I'm going to do is create an offset here. So I'm going to select this. I'm going to go inside 0.25 inches, quarter of an inch. And I'm done. So now I have basically 2 concentric circles. And the way I make this into a 3D object is very clever. So if you ever took that drafting class I talked about, you remember you may have to do these various views of your design in order to project that 3-dimensional shape. What Fusion 360 does is use tools like extrude and revolve to create those 3D shapes. So what I'm going to do is pick both of these surfaces, and I'm going to extrude. So we're going to choose the inner diameter and the outer diameter. I'll show you a 3D view here. I'm going to go down half an inch, negative 0.5 inch. So I can precisely specify my dimensions here. I'm going to bring that sketch back. And now I'm going to take just the inner portion, and I'm going to extrude again. But this time I'll only go down negative 0.4 inches. And I've got the bottom shape for the box, okay? Now I'm going to bring that sketch back again. I'm going to hide this body for a second. I'm going to take these same circles and extrude up this time. So we'll go up a quarter inch. Whoops, what happened? Oh, I turned off my bodies. Hang on a second. I meant to turn off this body. Okay, we're good. Let me turn off this first body to make this more clear. And now I'm going to flip this thing over. Just a second here. I can grab this, flip it over. And I'm going to do one more operation. I'm going to take this outer rim and I'm going to extrude it again. Let's see, so you can see this. We'll go up. Not that far, 0.125. Okay, so let's see what we have. We have this 3-dimensional object. I'm going to turn off my sketch to make this more clear. So this is the lid, and then this is the body. So you can see we have these 2 perfectly fitting together 3-dimensional objects, and that took me about a minute. So I used that same process for that heart-shaped box, and then I added some letters on top to give it that engraving. You can choose whatever design you want. Since Mother's Day is coming up, I put Mom up there. Fusion 360 also has a manufacturing capability, and this is where you can tell the tool how to cut out your objects. So for example, let me turn these things on, and you can see there are little lines around the heart shape. That basically is instructing a router to cut out the box. We can also, I'm going to go back to design here, take one of these objects. We'll take the bottom, for example, and we can save that as what's called an STL. And this is a 3D object that's basically a bunch of triangulated faces put together, but this can be used as input for a 3D printer. Okay, so basically this single program, I've created a digital 3-dimensional model starting from a 2-dimensional drawing, and then I can use that model for a variety of tools. So we have at Barn here a CNC router, which I use for the wood. We have 3D printers, which I use for the plastic box I showed you. And we also have things like laser cutters, and we have metal CNCs and metal lathes that can also be controlled digitally. So you can manufacture all sorts of objects out of all sorts of materials using these tools. All right, I'm going to stop sharing this screen. Okay, am I back? I'm back. And what I can show you is a quick video of the 3D print that I did. Just a second here. Oops, this is going to start without you. Hang on. Pause.
So the other comment to make there is that now that he's got that in a digital file, he can send that to anywhere to have it printed.
Right, and I'm going to show you one.
You could DM me that file right now, and I could queue it up on a slicer and have it printing downstairs in 10 minutes.
Yeah, hang on, I have to find, where did you guys go? Here you are. I have to now present a tab, and YouTube, 3box, here we go. All right, so here is one of our 3D printers in the studio. I'm going to click the play button and see if I can expand this. This was only going to take about a minute. Hopefully that's working. There we go. And you can see basically this machine deposits melted plastic onto a flat surface, and you can see the box is growing. So it starts from the bottom layer and then works its way up to the top. And it's done. All right. So I'm going to stop that. Oh, I'm not sure it actually finished there, but you get the idea.
I have some video of that kind of thing too. So
yeah, good.
If you want, I can use that.
Yeah. And let me just show you one more thing so you can get an idea of the process for the CNC. So let's see, I'm going to share a window. Here we go. Share. All right, so these are my finished. You see the boxes that I made out of wood?
Yep.
Great. So I'm going to go back and just show you. This is the top after it's cut off, and you can see I've done 2 of them. So the other nice thing about doing this with the digital design is once you have that design as you like it, you can basically become a mini factory and just start cranking these things out in quantity and selling them at the farmer's market if you want. So there's the top again. That's the bottom. So you'll see, I don't know if I can highlight them here, but they're little tabs that are connecting the cutout box to the walnut. That's so it doesn't go flying across the room after the cut is complete. So there's a little bit of manual intervention required here to actually remove those tabs after you're finished. And there you see I've made a couple of them. There's the box cut out with the original walnut. This, it's not a very interesting picture, but this is the CNC router in motion. Basically, there's a skirt to keep the dust collection working. So you can't actually see much action there. The bottom cut out, and what the bottom cuts out, what it looks like before I vacuumed out all the sawdust. All right, so I'm going to stop that. Okay, so I'll stop there. That was 15 minutes, perfect timing. And if there are any questions, I can take those now, or we can hand it off to Rick and he can go deep dive into 3D printing.
I just have a question, Doug,
Sure.
about how many people can be in the room at the same time during the COVID times working, or is it just one at a time usually?
No, it's studio specific because, you know, each studio is a different size. So in ETA, what we're doing now is we started out allowing 6 people in at a time, but we ratcheted that down to basically 4 members since we're seeing an increase in numbers again. So it's a bit flexible, but just to ensure plenty of room, we're allowing 4 members inside ETA. Wood shop, I think they might have gotten up to 15, but so what we're seeing is it's a bit self-regulating in that there's not a lot of people willing to come in, so we rarely even hit those limits.
Right. Okay. So yeah, one day though we'll be back.
I think so, and hopefully soon. Yeah.
I hope so too. So,
Yeah.
Any other questions? Bree, you have a question?
I see James. His lips are moving, but I think he's muted.
Okay, Jim, you can go ahead.
The raw materials. Sorry about that. I mean, how I can understand plastic and its components and so forth, but I don't understand how you do this with wood and.
Yeah. So to be clear, there are different machines for different materials. So the 3D printers use melted extruded plastic. And there are actually what the plastic is called when it's on the spool is filament, and that feeds in cold and then comes out melted. And people have come up with filaments that have like embedded pieces of wood in it, so it looks like wood. But that's not what I did. So the process of 3D printing is called additive manufacturing, right? You're adding material at each point in the process and then growing this thing. There's another process that's subtractive, and that's the CNC router. So basically you're familiar with a router in the wood shop, right? It's just this rotary machine that cuts wood. So you put one of those on a robot, and then you direct it to cut out, in circles or whatever shape you direct it to, and it removes material until it's carved out your object. And you can do, pretty sophisticated 3-dimensional models that way. So 2 different processes using the same 3D model, just different machines to implement those materials.
Essentially what that is a lathe then, or a router, something that routes the thing out.
Yeah. Exactly. So it's basically, it's a robotic router, and there are also robotic lathes. You can make chess pieces, for example, very intricately carved. At Barn, we also have a robotic plasma cutter. So you can take this sheet of steel and just direct the torch around the steel and then cut out a sign out of metal based on your design. So it's a hugely flexible, hugely leveraged technology, which is why I personally love it. So once you learn the design skills, you can then go crazy in terms of manufacturing without having to learn all those detailed crafts.
Does laser printing and laser cutting work in this process? I'm sure it must.
Yeah, so the difference between, say, the CNC 3D printer and then the other class is like that plasma cutter I described and a laser cutter. The difference is 2-dimensional versus 3-dimensional, right? So yes, you can use your same design, but you won't get a 3D model out of it. What you can do is just that initial drawing, and I can cut out heart shapes all day long on the laser cutter, for example.
Oh,
thank you.
Sure.
Hey, Reed, you were next.
Yeah, I was just wondering about the like you notice those little tabs that make sure that the carved piece doesn't go flying out. Is all that kind of stuff automated as part of the software program to anticipate that, or are you figuring out exactly how that works too? Yeah,
automated to an extent. So the user has to consciously make that decision, right? Because it's different for everything you want to do. So that's the hard thing about CNC versus 3D printing. 3D printing, you basically press a button and you say go, and the machine figures out most every other aspect of that. For CNC, you have to tell it the specific sequence of operations. You have to tell it if you're going to need tabs or not. You tell it where to place the tabs if you want to. It can do some of those things automatically, but yes, it's a lot more thought that goes into the manufacturing process.
Yeah, thank you. Sheila.
Yeah, I don't have a question because there's no way that I can ask a question. I don't think the entire time, Doug, that you showed us that my mouth closed. I was like,
well, okay. So again, let me tell you where I'm coming from. You know, I'm coming from a guy, you know, who doesn't have great drawing skills and doesn't have great woodworking skills. Yet I'm able to do these things that, you know, if you did them by hand would require real skills. So that's the attraction to me, is that you don't need, you know, to really have a lot of talent to do this. You can learn. So just keep that in mind.
I just love that you can use your imagination, though. You know, you learn the skills, and then your imagination could go crazy.
That's what I love about it. Is basically you can take whatever you can think up and design it, and you can make it a real object out of it. So that's what's great. Yeah.
Well, great. Thanks, Doug. So
right.
we ready to go on to Rick? Are you ready?
I'm ready. Yeah.
All right.
So anyway, my name is Rick Gordon. It's funny because I have a similar background. Actually, I had, you know, we had wood shop and metal shop and drafting when I was in high school. I didn't get to do small engine repair, but I did go into photography and computer stuff. And I still do pretty much, well, I do mostly photography and computer stuff now. Occasionally woodworking, not a lot, more along the house kind of stuff. And I do a lot of the photo work for Barn, as well as some of the video work that goes on there. So I'm carrying on stuff that I started doing in high school. Now for this stuff today, I can show you a demo first, and then I can do an overview. I think that would be fun to do. So let me launch that. We just so we have some context of what everything looks like when it's running. As soon as this guy launches, pause that. All right, so you're seeing my screen, and you should hear the audio coming from this. And if you're getting audio, but I'm actually just walking through the process of selecting a file, heating the bed. There's the printer. The printer is now setting itself up. It's going to calibrate itself to the current bed position. Rehomes itself, we call it. Are you hearing the audio from it?
Yes, we're hearing it.
Good. I can't hear it, but it's echo cancellation here, I think. So we change over. It starts extruding that melted plastic. It smears some out on the bed to clean it. Now it starts drawing it onto the hinge. And like I said, it's like drawing with a hot glue gun, controlled by a robot. Get a little closer view here. You can kind of see the first bits going down. And it just hops as it's moving around. You can see it hopping up and down. I'm also using it because it's a process. It takes about 30 minutes to do this little toy. We're going to speak to it a little bit closer. You can kind of see it starting to build up the walls now. A little, just trying to get different views. You can see stuff running. You see, basically, the y-axis is the thing moving back and forth. So at X and Y move back and forth, and then Z is just moving it up all the time. And there are different designs for this kind of printer. Sorry. Almost done. See it moving along. You can see it's got most of the walls done now, and it's finishing up its top layers. It's showing it's 93% done with 2 minutes remaining at this point. And that's done. Pulls over to the side. Now it's on a flexible metal plate. It's stuck magnetically, so I peel it off to loosen it. And then grab it off, and there you have a JP whistle.
You gonna blow?
I'm not going to blow it. I don't have that one handy.
That's amazing.
Yeah, it's kind of fun to watch. I mean, you can just sit there. It's kind of like watching the dryer spin for a little bit, you know, a little more interesting than that, I guess.
I was going to say, do you go out for a cup of coffee when you and then come back?
Oh yeah, you don't. I mean, once you've seen a couple of them, you learn to, okay, that's what it's going to do. I'll come back in 20 minutes.
Right.
I will choose my tab. It's this guy. All right, so this is kind of a quick slide deck that I use for a class that we teach every month. So I just pulled out some of the highlights from it. So I'll go through it a little bit. Any questions, you can ask me as we're moving along. So we talked a little bit about it. Doug already mentioned some of this stuff, that this is an additive manufacturing process as opposed to a subtractive, because we are basically building objects in thin layers. And there's two aspects that you have to remember: the speed, and you just saw how the speed is, and that was just a little glimpses, but it takes a little while when you're creating something in thin layers. The layers are typically 0.1 to 0.3 millimeters thick, so it takes a little while. And then, in terms of limitations, it's kind of limited by, well, your imagination in terms of what you can imagine creating this way, but there are a few laws of physics that come into play during the manufacturing process. So you can't just create things in midair, for example.
Rick, I have a question. I mean, if you upsize this whole thing and build a plant, you should be able to create affordable housing complexes in a factory that can be shipped to a site. Is that realistic?
It's realistic, but actually I think what's more also interesting is that they are now using it. They're shipping the robot to the site and building the house on site.
That makes sense. That makes a lot more sense.
Yeah, it's kind of like taking the tool to the data rather than, shipping it back and forth. So there are definitely, I mean, it's still, I think, in its infancy, but it's definitely happening worldwide.
Thank you.
Yeah. A quick overview: there's different kinds of 3D printing. The kind of ones we usually hear talking about is fused filament. That's the kind of stuff that we do at Barn. We're just building layers of plastic. In some more industrial settings, they use what's called selective laser sintering, where they use a powder that has usually metal in it, as well as some other bonding agent, and it's heated with a laser and used to create a model that way. And then there are a couple of forms that use other lasers. There's a polymerizing a resin with a laser, and then there's another kind which polymerizes a resin with a masked ultraviolet source, basically an LCD panel on front of a UV source. The SLA ones are relatively expensive. They're in the few $1,000 range. The masked SLA ones, though, are in the cheap range. They run from $200 to $1,000. The sintering ones, I think typically I've seen them around $25,000, and then the FFF printers start at $200 and go up to a few thousand. So.
Rick, can I ask a question real quick?
Yeah.
When you were all through with the whistle there, was that hot when you took it off the plate?
No, it cools pretty quickly. There's a fan there that cools it as it's coming off. That said, I mean, the plate was still warm. The plate is heated up to around 60 degrees centigrade. So, depending on how sensitive your fingers are, you don't, just touch it, let it cool down for a few minutes, and it cools pretty quickly. You pull the plate off the bed and it cools off there too. So, but yeah, we use heat to hold it onto the bed.
Okay, so it doesn't stick to the bed. That you have problems ever getting it off the bed?
Yeah, usually the problem is getting it stuck onto the bed, but there's also sometimes a problem in getting it off the bed depending on the material used.
Okay, thank you.
Yep. There's this whole thing called the Reprap printer, and the Reprap is the self-replicating activation. I don't know what it stands for exactly, but the notion is that it's a self-replicating device. Patents started running out on 3D printing technology in the late 90s and early 2000s. And so at that point, then a community started forming around the notion of building 3D printers. I think University of Oxford created one of the first ones in around, I want to say 2003 maybe, but I'm not sure the exact date, around that era. The Darwin was the first one that I saw, and that was, looks like it was initially created around 2005. I ran into a guy in a hallway at an open source conference in 2006 carrying this thing around, and I followed him until I had a chance to ask him what in the world that thing is and how does it work. And he showed me. So that was my introduction to the whole field. After that, the open source community really kind of evolved around this and building up the technology for this. And for a while, by say 2009 there, that printer in the top center was, you bought parts at a hardware store, you ordered a couple of electronics boards and some motors off the net, and then you found somebody on eBay or in the community would print out the parts for you. And they'd send them to you, and you would build a printer, and then you would say, okay, now I can print parts for other people. So that kind of evolved. You can see the evolution there from the square cube in 2005 to the triangular support structure in 2009. And then Prusa got involved with it. Joseph Prusa is his name, and he's a mechanical engineer, I guess. Yeah, he started putting together some designs and refining it around that. You can see 2010, 2011, and a few years after that, he created a company and started selling them. And they sell them in kits, and they sell them fully assembled. These are the ones we have the most of at the barn. They're pretty rock solid. They tune, calibrate easily. They're fairly easy to use. So kind of it's interesting to me to kind of see that evolution of them there. Go.
Doug clarified something for us that Reprap is short for Replicating Rapid Prototyper.
Thank you. Yeah, I knew it was something like that.
Yeah. For us who have no idea what.
Yeah, I know. We just call them Reprap.
Reprap. Thank you.
So, yeah, sure. In terms of some example print jobs, I have things there. That little boat in the top left is actually an object that has enough challenge to print that it's considered a benchmark test. If your printer can print this, then that means it's well tuned and well calibrated. There's other things. There's a lot of mechanical components that we can use. That those pieces on the right there, that orange piece that looks like a lift is actually a piece of a camera grip, a camera mount. That it actually ships. So they sell this machined in metal for about $150. But for $25, you could buy a kit that contains all the black metal bits, and you can download the files for the rest of it and print them out yourself and make the part. So they've done a couple of things like that now. I think that idea is still in its infancy, but it's out there. It's happening. And parts like that stuff in the upper right corner there, that orange part in particular is a part for another printer. And you can look at that thing and realize that it's actually a fairly complicated part to try to machine out of something. But building up from a 3D printer is much easier in this case. Or, down in the lower right corner, we see those are boxes that were used to contain computer boards. Those are particularly for Raspberry Pi boards, actually. A couple of different designs, one that slides in, one that clamps in. And then over in the lower left, you can also do weird things like, print hinges in place. So you can print an object that basically has a hinge there and it moves itself. And that's what that is, the skull. The skull is printed as one piece, and with the hinge there, and if I had my on-screen view, I would illustrate it with my hands. But the basic idea is you print the pin and you print the hinge around the pin as it's going up. So
very cool.
Yeah. And then, there's there's people with skills in 3D modeling, and they can make things like dragons and rabbits. And then sometimes there's one like a lower left, that's basically the digits of pi wrapped around in a spiral all the way down. The top right one is kind of a cone as of a tornado that's just been twisted manually and turned into a vase. The thing on the lower right is another vase, a simple idea where you take a simple shape and then twist it on the computer and you can print it out. And the other thing to note here, the color change is caused by the filament itself is actually comes out in different colors. It's like a gradient effect. So something else that's happened in the world, and we see this, is that a lot of museums have scanned some of their collection. So that Triceratops skull in the center is one of those 6-footers that came out of some museum in France. The owl on the right is the owl of Athena from, I don't even know what museum it's from. And then, of course, there's the Egyptian god on the left. You know, they have fairly high resolution scanners, and they can make really good 3D replicas of things. Just anecdotally, I saw somebody building a replica of Michelangelo's David for some project. And they're doing it in parts, of course, but something to think about. And then, you know, another thing is your colors are available there. Now, this is a couple of different things. The circle of frogs on the left are just, as I got a new roll of filament, I would print a frog in it to see what it looked like. So I started building up a collection of frogs in different colors now. But we have a printer that can change filaments at different times, so you can print out more complex objects in different colors. And those are just examples of that. I like the little topographic map there on the left, for example. There's another thing that's kind of fun. This is kind of a reimagination of something that was popular in the 19th century, where they would make they would carve designs out of wood. They would pour a porcelain into it, fire it, and then frame it and put it in a window, shine light behind it. You have a negative image that turns into a positive. So these are printed in plastic. And I did a couple of them here. The one on the left is printed flat on the bed, while the other one on the right was printed vertically, and it's curved to try to hold it up vertically. And I've experimented with some in different other printers as well that are kind of ongoing, but I think it will work well. But these are just pictures of the front of barn that we took and turned into a lithopane. We mentioned a little bit about the resin printing. Now, we don't have these at barn because handling the material requires, it's somewhat toxic, and it requires special handling and special disposal. So we don't, I use these in my garage basically in the summer, and when I can wear a respirator and gloves and everything. So the one nice thing about it is when COVID hit, I had a respirator and a supply of nitrile gloves and plenty of IPA alcohol. So, because it's all used in this process. But, you know, the resin stuff is nice because you can get an even finer level of detail than you can with the filament printers. You see that used for jewelry casting, for example, or for objects that are a little bit harder to print on the 3D printer, on the other 3D printers. My personal favorite, well, there's two of them really. This Eiffel Tower here is about 6 or 8 inches tall, takes several hours to print, but it's incredibly fine detail. And then there was a cover on Atlantic Magazine back, I don't even know what decade it was in. I want to say the 2000s, it might have been earlier, but it was basically the idea of a factory on your desk. And so somebody took that drawing and made a 3D model of it, and there you see it. And that thing is really only about 2 inches high by 2 inches wide. But it's a little factory, and it's cranking out a car and an airplane, and you can see it's got a little smokestack, and there's a little cat on the rug down beneath his feet. There's a bird perched on the back of his chair. You can see the pattern in the rug, etc. It's pretty nicely detailed. During this whole COVID thing, as the need for protective equipment arose, Barn and others started getting involved with making it for different groups. We were mainly involved, I guess, with 3 groups. There were Masks for Docs in Seattle. There was a group of people in Kitsap hosted over in Silverdale. And then there were some people on the island that were designing papper equipment. And then there was some stuff internally for the people making masks internally. I don't know, your barn people sewed many thousand masks, and those things on the right are little jigs that were used for the bias tape as part of the sewing process. The top middle is something that's an interesting project because it's done by a third-party application that runs on your phone that scans your face, builds a model of a frame that fits your face, and is used to tie on over a surgical mask or a KN95 mask to give you a higher level of fit to that. And I guess early on, Bainbridge Prepares was using that for a lot of the local medical providers that didn't have PPE equipment, sufficient PPE equipment for their staff. And they were testing that and everything. And they said they had a very good fit with it, and enough that people were confident using it. So, and then the things on the left are just a couple of face shield frames, a couple of different designs that we were doing. I think Doug designed these parts on the upper right. There was a coupler for a papper hood that was being laser cut out of Tyvek. And so it was kind of a multi-part solution there. I don't know who designed the bias tape jig. And and then the bottom left is just ear savers, and I printed them in different colors just to make them more interesting to people. We even had a UW edition there in purple and gold. We talked a little bit about filament. So this is what it looks like coming in. It usually comes in a 1 kilogram spool, although sometimes you can buy it in like 10 kilogram spools if you have the room for it. And comes vacuum sealed. You typically want to store it in a dry space, and you want to keep it wound tight, I would usually mention. But around here, our environment's not too terribly humid that we don't have as big of a problem. But overall, you want to keep it dry. It will absorb moisture over time, and some are worse than others. A quick overview of the plastics or the materials used. First of all, the color coding scheme is relevant to barn. So anything in green is something that we can print with easily. Anything in yellow is something that requires special handling, and anything in orange is something we can't print with right now. So, but there's a variety of plastics and plastic blends. Doug mentioned the wood additive added to it. Well, there's also carbon fiber added. And then you get into the photosensitive resins, the powders, pastes. There are edible paste printers. You can use it to print chocolate. You can print fondant, et cetera. And then, of course, there are the people doing wet lab work where they're printing cellular scaffolds for parts to grow in the lab. We don't do that. This is just a quick overview of why you would choose different kinds of material. Some of them are easier to print with. PLA is cornstarch based. PETG is really nice for mechanical parts, and it sands down well. TPU is flexible. ABS is stronger. The wood filled, I just mentioned because it gives this kind of a coarser wood grain texture to it. And then some different brands that we use. A little bit about the terminology, and then I'll show a little bit about workflow here. So we have this notion of an STL, and that's basically a mesh file that surrounds an object. We have 3MF, which is a file that contains the geometry of the object as well as some properties and settings. G-code is the instructions for driving the actual machine, and that actually comes from the CNC world and has evolved over time, but the same instructions still apply. So all these computer-driven robots today, the CNC machines, the wood ones, the metal ones, the plastic ones, even the laser cutters are all driven by a form of G-code. The slicer is what's going to take our model and turn that into G-code. So we have a quick workflow here. Doug showed you that little design process there. I mean, that's probably the hardest part of the thing is designing the model. Once you've done that, you turn that into an STL file. Use a slicer to slice the model. Use that to generate your G-code. You send that to the printer and you print your file. And that's the whole process. Quick note, especially with plastics, most of them are sandable and paintable. I usually, a combination of files and a deburring tool and a sanding sponge and maybe a pair of pliers to clean off some rough edges or something is all you really need. I mentioned the notion of being able to print in the air. You can't print in the air. So when you do need to print something that can't rest on the base, you have to build a scaffold underneath it. And that's to do that is called supports. And here you can see that Triceratops skull we saw a few frames back. That's how it was actually printed. So all that area below it here, I don't know if you can see my mouse or not.
Yeah.
Okay, good. Then all that is just the scaffolding that was used to hold it up. And the same with this. This is a shape that is just two circles twisted perpendicular to each other and then printed. Well, there's no way to print that without a support. And I show that one here because we're also using a different form of plastic called polyvinyl acetate, which is water soluble. You can kind of see how the color changes there and there. And there it's been soaked in water for a little while. And so it gets gummy and you can peel it off a little more easily. And I just have to point out that, it's a mechanical device and, there are things that, anything mechanical always has some sort of a failure mode to it. These are a couple of problems that I happen to capture pictures of have occurred over time. I really don't know what happened to the one on the left. I think someone tried to hand wind the plastic on a spool or something. I'm not sure. And the one on the right, I think that the plastic just came off the bed and started dragging around the bed and created a nice little spaghetti mess for me. But, it's easy to clean up usually. And I'm not going to really drill down through it. Unless you want me to do it, I can take you through there. If you want, I can do a quick demo of that slicer. And then I just point out there's modeling software. Doug pointed to Fusion. There's a bunch of other ones available as well. Blender, FreeCAD, OpenSCAD, and Tinkercad are all good ones with varying degrees of learning curve available. Usually I tell people starting out to go to Tinkercad. It's easy, it's free, and it's really quite powerful. And a lot of people actually don't go beyond Tinkercad. They just use that for the basic kind of stuff they're doing. If you want to get into really, detailed parametric designs and stuff like that, then you start getting into the more of the Fusion and FreeCAD and whatnot. And if you want to do more of a declarative thing where you're used to describing what you want to build in a language, then you would use OpenSCAD. And then Blender is a tool that is used for 3D modeling and design, which just happens to be also useful for 3D printing in that case.
Hey, Reed asked, what is the starting skills of most of the folks at the studio?
It really varies, honestly. There are people that come in there with CAD backgrounds and mechanical engineering backgrounds, and there are people that come in there just like with jewelry backgrounds or just basic 2D drawing and say, well, I'd, like to make something kind of thing. How can I do that? So we try to guide them on that path.
Right. So
Rick,
and
good. I was just going to suggest you talk about repositories. So you're about to do that.
Yep. There's a lot of places online you can get prepared models for you if you just want to start out and see what's there. These are listed alphabetically, but I would actually start at the bottom and go to Thingiverse and Imagine as the place for a lot of different ones. The My Mini Factory has a lot of stuff that's oriented toward gaming pieces and whatnot, but they also have all the museum scans up there. So they have a little sub area called Scan the World. I would say that I don't know that all the objects they have up there are 3D printable, but they're pretty cool. So Instructables will often have stuff. Libre 3D has some stuff. NASA has a lot of 3D models, some of which are suitable for 3D printing. And the same with the National Institutes of Health. They have a lot of 3D models of stuff, and some of them are probably useful for 3D printing. And then the Smithsonian, and then Prusa. Prusa, of course, has a bunch of stuff. The Smithsonian has some stuff. So, and there's probably others. I just listed ones that I could think of. Online, if you just want to learn more about the industry or about printing in particular, there's a few different sites here. 3dprinting.com and all3d.com are pretty much more about the industry. Shapeways is a place where you can order things printed if you want to have them printed in metal or some other kind of thing. The Reprap wiki page is kind of where the whole Reprap community resides. And then the Prusa places, they're more centered around Prusa printing. Same with Ultimaker. That's another manufacturer printer, of which we have one of at the barn.
Mm-hmm.
So that's all the prepared slides I have. If you want, I can show you some close-ups of the printer, or I can do a quick demo of the slicer if we have time. I don't know what we have here.
We have about 9 minutes, but
okay.
I don't know. I kind of like to see the slicer.
Okay.
How about y'all guys? You want to see it?
I'd like to see the slicer demonstration.
Yeah,
definitely.
All right. Let me stop presenting. Switch back to here. Okay, you're seeing my screen now. Good.
Mm-hmm.
Slicer is just an application. It's downloadable. It's free. It runs on the Mac, it runs on Windows, and it runs on Linux. When you first open it up, it's going to be, it shows you the bed. Generally what I do is I select the kind of printer I'm going to want to use first. I select the kind of quality I want to use and the kind of filament I want to use. At that point, I want to add an object to the bed. I happen to have some files here. I'll just put them on here. Actually, I wonder if I have the whistle handy or not. Well, at this point, I placed an object on the bed. You can see this is just a cube with a number 1 on it.
Mm-hmm.
I was using it for testing something. I can make that cube bigger. I can make it smaller. I can rotate it. I can move it around. Scaling it is usually the easy one. I grab a corner and I could scale it all at 100% kind of thing, or I could just make it taller by grabbing one dimension.
Mm.
Okay.
Very nice.
So now I say, well, I have this block. I want to see how it's going to print. I'm going to do a little thing here. So at that point, I have sliced it. That was very fast. I don't know if you can see. You can't see the screen on the right, can you?
No.
Let me move this over. No, I guess you can. I'm just seeing it. I'm seeing it backwards. That's why.
Oh,
okay.
Okay.
Yeah. So you can see down here that it shows me that's about 1.5 meters of filament, about 4.7 grams, and at whatever cost I entered for that filament, that estimates the cost for me at 13 cents. And it will print in 35 minutes. Now, the fun thing about this is that I can see what it does. I can look at this guy as it's printing. So we can see the first layer down here in different colors. This shows me, it prints what's called a skirt to clear the head, prints the outer and the inner perimeter, and then it lays down the first layer. And then it just goes up. You can see it going up. Mm-hmm. So it's going to do that bottom layer. Now it's putting a fill pattern in there. And this is a complex printer called a gyroid. Now there, I can do this. Now I can go this high. Oops, let me see if I can do this. Anyway, so you can see that's the whole process, and then it will finally build it up. Now, at some point I can say, you know what, at this point, I want to change it. And now I've done it is I've created a color change event. And so now what will happen is this guy will, it still says 35 minutes, but when it hits 15 millimeters high, it's going to stop, unload the filament, and beep at me and tell me to come in and load new filament so that it can keep printing from there. So it's kind of a little, that's like how I printed the ear savers, for example. I just told it to change filament color.
Oh, okay.
And you can do that in multiple layers if you wanted to. And there's other options you could do here too, but it kind of gives you the rough idea. If I come back to my slide, I say, you know, this printed really well. And now, you know what, I'd like to actually build a plate with several of these guys. There is a way to do it. And this way is one. Okay, I'm just going to put a few of them on the page here. Now we'll create a build plate with all these in here. And now I can slice it. And now I can say that, okay, now it's going to take 2 hours and 20 minutes and it's 66 cents worth of plastic. But it's still the same thing. It's still going to copy that same whatever I had there. So
you have multiple colors of filament in the contraption, the machine, and you can go And you can do a gradient thing, so it can go from one color gradually into the next, right?
Well, that depends on the filament you're using. There are filaments that change color within the spool of filament.
Oh, okay.
I need to go back on screen. So, and that's the gradient filament I was talking about. So that's one way. The other way is you can actually change. You can have solid color filaments and then just change from one roll to another as you want to. And we actually have a third way that I can briefly show you, and that is we have a printer that has 5 filament channels in it, and I would have to break it apart. But if I do this, I think I can. Yeah, I have to do this, and now I could set this one and say I want this one at channel 3, and I want this one at channel I don't know, whatever, 4 we'll call it, and we slice it again, and that will actually create different colored objects on the block. So that's a little more complex thing. In fact, I've been preparing a class for that. That's why I had that test block there on it. But that's the basic idea. So you can do all that. There's even another little trick you can do. You can basically tell it to, let's go back, see if I can do this now. I know I have to reset everything. There's a way you can basically tell it to just cycle through all the filaments you have and rotate through them every X millimeters or something like that. So you can
program it just to do lots of different.
Yeah, it's kind of the advanced features of it. It's a little more, but it's.
Doug wanted to let me know that the contraction is called a 3D printer.
yeah, that's okay. It's not a thingamajig, too. Or whatchamacallit, yeah.
Is there a question? Howard has a question.
So could we go back to the museum pieces? How do you get from that complex 3-dimensional object and get that program into the? Does the program just read the whole thing and do it automatically?
No, it's definitely a process. You would have to start with a high resolution scanner. And that would build a point cloud of the model. And then you would have some software that generates the proper mesh from that point cloud of the model. And that would be your STL file that you then could print.
But the scanner is going to be, of course, 2-dimensional.
No, the scanner is a 3-dimensional scanner.
Oh.
That's why I say it's a high resolution device.
Yeah, Rick, you may want to mention a phone can act as a 3D scanner.
Yes,
right?
Now they can. Some of them can.
So basically you can take images, multiple images all around the object, and there's software that stitches them together and makes a 3D model.
Yeah, that's called what? Photogrammetry.
Yeah.
That's one style. There's another kind that uses a laser that points that out. And then there's another one that uses a LiDAR scanner, which I guess that's a laser too. So yeah, some of them don't use a LiDAR, some of them do.
Right. The museum quality scanners are typically $20,000 scanners, but you can actually get a pretty good scan with your phone.
Yeah, I'd like to try the new iPhone and iPad have LiDAR scanners built onto them, honestly.
Oh, that is amazing. That's unbelievable.
It seemed to me when I was at Thermopolis out in Wyoming, they have a museum out there, of course, the Dinosaur Museum. And in order to fulfill the replicas of the dinosaurs, they may not have all of the pieces, but they used this technique, I believe, in order to fill out the different parts of the dinosaurs that they did not have, and they looked like real.
Yeah, no, I think they've done that at the one in Seattle too, the Burke Museum. I think they have some 3D printed parts in their skeletons.
We've had one member who came in who had an antique elephant carving. One of the tusks was broken off, so he wanted to scan it and then make the second tusk from the first. So yeah, it's technology.
We have a low resolution scanner there. It's not going to generate museum quality scans, I can tell you that. But you can get a rough approximation of something that probably if you were a little skilled with 3D modeling, you could use as a basis for a print.
Oh,
Wow.
that is just fascinating. Oh,
Yeah.
thank you so much. Well, we're going to call it a day, and thank you so much. I hope that I'm going to be sending this video along to many other friends who work for NASA. Actually, I want them to see this. And Doug and Rick, thank you so much for joining us today.